What up, everyone? Let me make sure this is going to work for me. I have a problem where I get like overhyped when I give talks because I'm like really nervous. So I'm going to try to keep that shit under control. I also end up cussing a lot, so forgive me in advance. Basically, you're probably looking at the screen and you see the title of this talk and you're thinking just what that stick figure is thinking. Like, is this fucking guy really going to explain everything I ever want to know about web authentication in Node? Which is why I'd like to officially amend the title of this talk to almost everything you ever want to know about authentication in Node. The reason why is because I've been working on this sort of thing for a few years now, and what I've come to learn is that I can cover like almost everything you want to know, but people ask for crazy stuff all the time, so I'm doing the best I can. Anyways, my name is Randall Degges. I run developer advocacy at the company I work for, Okta. We're a security company. We do some cool stuff. If you're interested in what we do, you should hit me up afterwards. I also do a bunch of Python and Node and Go. I write a lot of open source libraries. I run a lot of open source API services. I write tech books. I give tech talks and do all sorts of random things on the internet. The other thing you should know about me is I'm super duper casual. So throughout this talk, I prefer to have them a little bit more interactive. So if there's anything at all that you don't understand while I'm giving this talk, literally shout it out. I'll repeat your question. We'll make it super cool. But like, my goal is for everyone in here to learn something today, hopefully. So yeah. Anyways, what I want to show you today is the journey that a browser goes through as it's authenticating to a web server. And not just like, oh, high-level stuff like, oh, you got to do this, but like literally every single component along the way and how it works at a very intricate level, because this stuff is really interesting. Now, how many of you in here, raise your hands, have heard the people say security is really hard? Throw your hands up if you heard it. Yeah, so those guys were all completely wrong. So I'm going to show you that it's actually an easy thing, just like pretty much everything else in computer science, right? It all basically boils down to for loops and if statements at the end of the day. So what I'm going to walk you through building is a really simple website in Node that has 3 main pages, a registration page, a login page, and a dashboard page. And the dashboard page, of course, will require a user to be logged in order to access it. That's how we're going to like cut the scope of this thing to make it manageable. And oh, by the way, one other disclaimer. Everything you see here, like I've ran a bunch of times. So like if you were to type all this in, this will run. Just remember that. A couple assumptions that I'm going to be making about you. So A, you're at least a little bit familiar with Node and Express. Just a little bit. If you're not, no biggie, but just keep that in mind. The other thing is that you're at least a little bit familiar with the concept of databases and MongoDB. Now, if you're freaking out when you see Mongo in there, and Varun, I apologize. I didn't talk to you before. I should have. But like, I'm not a huge Mongo fan, so I put this in here. But basically, if you're a DBA and you're freaking out because I'm using Mongo in these examples, I just want to let everyone know I'm like a fan of Postgres, so don't throw the hate this way. But Mongo is fantastic for showcasing stuff like we're going to do today. Also, Mongoose is in here, and it's amazing, so you're rocking it. So the first thing we need to do, because I said this will run exactly as is, right? So we're going to cover everything, is we need to install Express, the biggest, most popularist web framework in Node, as well as Pug, which we're going to use for templating. Now, throw your hand in the air if you have no idea what Pug is. It's OK if you don't. All right, cool. I just want to figure it out. So basically, well, we'll cover that in a second. All right. So the project I'm going to be walking you through today is really going to be super simple. There's only a few files we're doing here. There's a server.js file, which is going to contain all of our Node and Express web server code. That's it. Really, really basic. We're going to have a views directory where we're going to keep all of our HTML code. We're going to have a base HTML template, which contains some reusable HTML we're going to use everywhere. An index.pug file, which is basically the homepage HTML, and then registration, login, and dashboard. The pug suffix is just saying that like this will generate HTML eventually using this thing called pug. So keep that in mind. Now, when we go to create the base template, I want to quickly explain this. So if you're not familiar with Pug, this is where you get the opportunity to learn it. It's sort of cool. Like everyone in here, I'm sure, understands HTML. You have like your opening HTML tag, your closing HTML tag. You got other stuff nested all inside of this thing, and it gets a little bit annoying to type that all day long. With Pug, we're actually writing the code on the left over here. So we basically write HTML just without the little closing tags everywhere. We use white space to indent things over. So because this head tag is nested inside of this HTML tag, it's going to automatically create the proper HTML over on the right. So it just makes things a little easier. The other fantastic thing about Pug, which is the part I really care about, are these things right here, variables. So variables make it really easy to make your templates dynamic without doing a bunch of bullshit. Excuse me. Okay. And finally, we can insert variables into blocks as well. So we can insert other HTML into this thing. So pretty much every page you're about to see is going to look really shitty because I'm not a designer, but there's not going to be much code in there because we're using these, and it makes it sort of nice. So let's move on to the home page. I'm going to go through this a little quick, but it's going to extend that base template. So we're basically going, what that means is we're going to be inserting the rest of this stuff into that base template to generate our home page. Make sense? Don't forget about the questions thing. You can shout them. The first thing we're going to do is define some variables. So right here, I'm defining a variable called title. So if you go to this previous slide, in our pug code over here, we're outputting the value of that variable. So on our home page, the title that gets fully outputted in HTML is going to say ssauth, and then the home thing that's right here. So that's how the variables work. We're also going to put the body of the page in here, and it's really basic. All it says is just register or log in to continue. Nothing fancy at all. Next up, this is what our registration page is going to look like. It's basically a really simple registration page. As you notice, there's an H1, so it says create an account. And pretty much everything else is just a registration form. So you got an HTML form. It asks you for 4 things. First name, last name, email, password. All super duper basic. Nothing fancy there. Then we have a login page. Our login page is just another form, and it only is going to ask you for an email and password. And that's it. So I know everyone in here is familiar with that. And lastly, we have a dashboard page, which is basically absolutely nothing. All it does is say, welcome to the dashboard if you view it. Now, alone, these HTML files don't do anything for us, right? You need a web server to actually start to build this authentication stuff. So let's define the world's simplest Express web server to make this work. So the first thing we need to do, oh wait, how many of you are familiar with Express? Throw your hands in the air. Okay, great. So you import Express, you tell it to create an Express application, all standard stuff, whoops. And then you tell it to start running this web server on port 3000. That's just saying, we're getting this thing running on our laptop so we can test it out. The next thing, anything that says app.set is basically configuration information we're giving to Express to tell it to do something for our app. In this case, I'm basically telling it all the HTML stuff we're doing is going to be using pug, and that's it. And then finally, all the other code in here are routes. So these routes, basically, what they do is they tell Express that, if a user issues a request to our server to get something, like for instance, if they issue a GET request to the / URL, like the home page of a website, then run this function. If we go in that function, we're going to say response.render and just give it the name of that HTML file from earlier. So what this says in layman's terms is if a user visits the home page, return the home page HTML. If they visit the registration page, return the registration page HTML, etc. Yeah? This is just straight up JavaScript. Now, I said I'm not a designer, and I wasn't lying. So this is, if we actually run this node project, and you take a look at this in your browser right now, like I doubt you guys were typing this down, but if any of you were, you can see I'm not lying. This is what it looks like. It looks like garbage. But we're not here today to do fancy design, right? So now let's talk about something sort of interesting. Authentication, when you talk about it, people usually talk about password hashing and like SSL and cryptography and stuff. But like the story around authentication actually gets started with like HTML. And no one talks about that, and it's sort of annoying to me. So you can't authenticate in a browser without an HTML form, because that's how you send information to the web server to say, log me in, register me, whatever that might be. So let's take a look at a registration form, for example. We have these input fields. The user can fill them out, hit submit, whatever. We have a submit button. But the most important part is the form method up here. In browsers typically support 2 types of HTTP methods. They support a GET request, which is where the browser is talking to a website and saying, hey, give me the HTML, give me some data. Then there's a POST request, which is where the browser is saying, I'm going to send you some data. So in this case, because this form is going to be sending registration data to our website, we want this to be a POST, and that'll be important in a second. Now, if we're able to send that registration data to our web server, the next thing we need to do in terms of building an actual registration page on our site is grab that data from the browser, right? That's like the next step. So what are we going to do? We're going to fucking grab the data, of course. So We're going to use the body parser library on NPM. Everything from here on out, by the way, that you need to install is going to be bolded, just to make it a little easier. We're going to import the library. We're going to set up a node middleware here, which basically is saying, for every request the user makes to our site, run this middleware function before our routes ever start. And so what this library is going to do for us is it's going to take the form data from the browser's request, and it's going to package it up into this variable called request.body. So the next thing you want to know is I defined a new route here. So before we said app.get/register to show someone the registration page. What we're saying now is, look, if the user is sending us data with a post request to the registration page, then we need to do something else. So what we're going to basically do here is we're going to say, yo, if the user sends us data on the registration route, we just want to output that data as JSON in the browser. So res.json basically just says output this data the user just gave to us. So if you go to the registration page right now and you're running this on your laptop, you go to the registration page, you fill in information, you hit go, this is what you will see. So just some JSON data being returned. OK, so we figured out how to collect information from the user and get it onto our server. The hardest part's over. The next step is storing that stuff in a database somewhere. And this is where Mongo comes into play. So Mongo is super cool because you can install it really easily pretty much everywhere. You don't need to know anything to get going with it. So I'm going to quickly cover the basics so we all have an understanding. The following stuff is typed into the Mongo command line shell. So they have a nice little command line tool where you can just mess around with the database. So the first thing you want to know is that to actually create a database for each of your projects, you can use the use command inside of Mongo. And these are things I just ran and copy-pasted the output of, by the way. So I'm saying use test because I'm just creating this test database that we're going to go through. In Mongo, you have a series of things called collections, which are basically just like different types of data you want to store inside of your database. If I run the show collections command, it's going to show me all of the ones I have, and I don't have any yet, so there's nothing. Next up, if I want to create a collection and insert some data into it, in Mongo, I do that in one command. I say db.collection name here, which in this case would be users, .insert, and I give it some JSON data. So what this is saying to Mongo is, hey, create this collection called users and put this JSON object inside of it. So we're storing something in the database. And then finally, if I want to show all the things that I've stored in my collection, I can use this find method, and that will show me what I just stored. And one thing to remember here, this is going to be really useful later. In MongoDB, for everything you insert into the database, by default, it creates this underscore ID attribute on that object. It assigns it a really long, unique ID, essentially. And that's going to come in handy. So now let's talk about Mongoose, which Varun works on, which is awesome. So you guys should hit him up afterwards if you have questions about it. But basically, once you install this thing, what it's going to do is allow you to talk to MongoDB in your node code way easier than the alternative. And it's really easy to use. Look, this is 2 lines of code. I import the library up here. Then I connect to it down here. And when you connect to it, all you do is you give it your database name, which in this case is ss-auth. You could change that to whatever you want. And then where it's running. In this case, I'm running it on my laptop, so I'm using localhost. And then finally, what we're going to do is we're going to define a model to work with. Now, MongoDB is schemaless. It means you can insert whatever the hell you want into the database. And that's all fine and dandy. That's fantastic. However, using models makes it way easier for us to write code to store stuff in Mongo and retrieve it, just because there's so many nice things you get with it. So for example, in our project here, we're only going to be storing user information. So I'm going to define a user model that has 4 fields: first name, last name, email, password. I tell Mongo what type these fields are. They're all strings. I say to Mongo they're all required. And I also tell Mongo that the email field must be unique. That means that 2 users will not be able to register on the website with the same email. It'll be an error. So that's pretty cool. Any questions? Good, right? All right. So now, let's go back into our registration code and let's modify this thing so it actually stores the user when they sign up. So what we do is, remember this thing from before, request.body, the form data? All we need to do is say, use this new model we just defined, and pass it that JSON data that the user's entering in the HTML form. Then when we call this save method, it's going to execute the query in Mongo, that db.users.insert command from before. It's actually going to run that. and it's going to give us an error if something failed. If nothing failed, then we're basically going to come down here and say, redirect the user to the dashboard page. That means they've been stored on, on the database, and now they're going to go to the dashboard. Now the error handling stuff here, I'll just point it out real quick. I basically say, if the database is down, or if the email has been duplicated, or if there's some other issue, I'll re-render the registration page. I'll show that HTML code again with a nice, pretty error message on there. Any questions? All right. So if you actually run this and you want to verify the user was stored, go into Mongo and say db.users.find, and bam, you now have a real user object stored in the database, so things are looking pretty good. So now, let's authenticate users. So we're able to store users now. We're able to register them. We're almost done. Now we just need to log them in. So just like before, we're going to define a new route that supports post requests to the login page. And what we're going to do is we're going to use that same model we defined earlier, and we're going to say user.find1, and pass in some search criteria to the database. Now what this is going to do is it's going to tell Mongo, hey, find one user whose email is equal to the email that the user inputted on the login page in the login form in the HTML. And if there's an error there, so for instance, like if we can't find the user that Mongo returns to us up here, or if the password the user's entering is not the same as the password stored in MongoDB, then we're basically going to re-show them the login page and say, hey, this is an incorrect email or password. And if everything works perfectly, then we just send them straight to the dashboard. Making sense? Don't be afraid to shout out questions. All right. So now let's talk about the fun stuff. So that's the easy stuff, right? Let's get into the fun stuff. So, sessions. So wouldn't it really suck if every time you went to a web page on a website, you had to re-enter your login credentials constantly on every single page? That'd be horrible, right? That's sort of what the web was like back in the really early 90s, I believe, because there was not really the concept of like session management yet. So sessions basically make it possible to not have this issue. The idea is that when you log in from a browser to a website, the website's going to send back some unique identifier to the browser that tells, that explains who you are. And the website's basically going to say, hey, remember this value. I need you to send it back to me the next time you visit so I know who you are. So basically, the website's saying, yo, I don't want you to type your password into my site every single time you view a page, so you remember it for me, or remember some identifier, and send it back to me to remind you who you are every time you visit the site. And that's what sessions are. Cool. Now, how do sessions work? They work via cookies. Now, how many of you know how cookies work? Pretty much everyone, right? But how many of you actually know like the way they specifically work, the low-level way that they work? Okay, a few people. Cool. So the high-level flow of it is that when you authenticate to the server and you send your email password or whatever from the browser, the server will basically set this unique ID for you inside of a cookie, send it to your browser, and the browser will store it. And the browser will basically say, hey, every time I make a request to this website again in the future, I'm just going to send whatever's inside of this cookie right back to the web server. But before we can understand the mechanism by which that works, we need to understand the different ways that like HTTP requests and responses are formed. It's really important. So in HTTP, there's really only two things you can do. You can say, give me data, or you can say, I'm giving you data. So there's a request and there's a response. Those are the two different things. Now, requests and responses, they all have the exact same format. There's always two parts to a request. There are the headers, which are up here. This is basically a key value store. So there's a piece of data on the left, which is the key, and a piece of data on the right, which is a value. So typical ones you probably see all the time are there's like a user agent, which your browser sends to every website you ever visit, which says like, I'm using Chrome, or I'm using Firefox, or I'm using Safari. And then there's the body of the request, which contains the actual information that you care about. So for instance, like if I'm trying to view the login page, the website's going to send me back HTML in the body of my request, because that's where all the cool stuff is. The way that cookies actually work is that they're just headers. They're HTTP headers. For the longest time, I always assumed they were files, or there was some special like browser thing that made them work, because clearing cookies to fix website problems and stuff always felt like a file-based operation to me. But the reality is they're just strings in an HTTP header. There's nothing fancy about them at all. And to create a cookie, it's actually really easy. Let's say a browser makes a request to your website. If you want to store a cookie on that browser, all you need to do in your response is add this set-cookie header, and then set a cookie value equals, or sorry, a cookie name equals a cookie value. So in this example here, I'm basically saying create a cookie called session. Its value should be 1, 2, 3, 4, 5, and stored in the browser. If I wanted to create multiple cookies, I could do that by just adding a semicolon and then adding some other cookies at the end. So next up, reading cookies. So we talked about how to set them, but how do we actually read them? Well, the way we read them is almost exactly the same, except instead of the header being called setCookie, it's just called cookie. So once the browser is storing these cookies, it will basically append this cookie header to every request back to that website. Makes sense, right? Cool, not so bad. So now, how do we work with this stuff in Node, right? This is where the client sessions library comes into play. Now in Node, in the Node world, there's quite a few different session libraries. Like the most popular one is called Express Sessions. I'm actually not a fan of that. So I recommend people use this library instead. It's called Client Sessions. It's built and written and maintained by Mozilla. It uses really strong cryptography. I highly recommend using it. I also contribute a little bit to it. And the way it works is really basic. You install the library, and you initialize it as a middleware. And what you do is you tell it, what cookie name do you want this library to manage for you? In this case, because we're basically going to be storing a user session, I'm going to name the cookie session, but you could call it whatever the heck you want. Then you define a secret, and the secret is basically a really long password that you need to keep secure. So this is something, for instance, you would not check into GitHub. You would store it in like an environment variable on all of your production web servers. You would never post it publicly to the world. It's what handles like the encryption of your cookie information. And then finally, you would go to this duration field here, and you would basically tell it, how long should this cookie last? Like, do you want this cookie to expire after 30 minutes and make the user re-log in on your website? Or do you want it to last for a day or a week or a month or a year? That's configurable right here. Yeah?
Is there any specific reason why like, you're not using Express Session and using the client sessions?
Express Session doesn't support the same strength of cryptography as Client Sessions does. I can get into the specifics afterwards if you want, but I would probably bore a lot of people with that. Yeah.
Why not JSON Web Tokens?
So actually, I could give a whole rant about why JSON Web Tokens suck for this. But essentially, they're extremely bloated. So compare these two. Just think about this for a second. And I'm sorry to anyone who's not familiar with this. But JSON Web Tokens are an extremely inefficient way to do web authentication. They are only useful if you're doing API authentication and token authentication specifically. If you're using them to put inside of a cookie, you're losing all the benefits of JSON Web Tokens because their only benefit is that there's JSON data that's cryptographically signed. Cookies are already cryptographically signed, and most of them are encrypted like they are through here. So you have two levels of signing, which might sound cool, but is completely pointless and slow and blocks your event loop. Yeah?
But, I mean, otherwise you need to have, like, database, like, you have additional overhead.
No. I can talk with you about that afterwards, but that's totally wrong. Yeah, they're not, the stateless benefit is like a lie. Yeah. I saw another question, or are we good? Good? Okay. All right, cool. Oh yeah, and if you wanted to know, can this library support using, managing multiple cookies? The answer is fuck yeah, it can. You just copy paste this shit down one line below. So pretty easy. So if you copy paste this below, just rename the cookie, rename the secret. It can manage as many goddamn cookies as you want. So there you go. Now, let's talk about using the session. So we have session support now, right? But if we want our website to actually remember people when they log in and register, we actually have to implement that, right? So let's do that. Let's start by implementing session support in our login page. The way we do that is we just add this one line of code down here. Isn't that cool? Just one line of code, you guys. All we do is we say request.session.userid equals user._id. Now, this value right here, on the login page, what we're doing, remember up here, we're using Mongo to find the user by their email address? We're getting the user object back. And remember before I told you that Mongo stores an _ID property, which is a unique number for every single user? Well, that's what this is. That's a great unique way to identify our user, and so that's what we're going to be using to remember who people are, is that unique ID that's in the database. That's a lot more secure, by the way, than storing like an email and a password or something like that. But that would also work. But don't do that. All right. Anyways, the other thing too is that that client sessions library we're using is what makes this left side of the equal sign possible. So it gives us this request.session object and lets us tack any extra data onto it that we want. So that's how it works. Now, oh my God, hold on. 1 second. We have to see this. It's going to be so cool. You guys will never believe me otherwise. Oh, I just got the request. Cool. Give access. Nice. Oh, wait. Send. Here we go. Let's just refresh this because it'll be a little easier. I apologize. Okay, present. Okay, so here we go. Now, check this out. This is me showing you exactly what benefits you get from using this library. I'm going to log in on the login page, and what I have up here is the Chrome inspector. And what I'm going to do is when I log in, I'm going to go ahead and copy the response headers that the server sent back to see what they look like. So we can actually see that set cookie thing from earlier. Now if I paste it in here, you see how it says set-cookie equals, and then it says session equals, and a bunch of nonsense there? That's an encrypted and cryptographically signed cookie value, which is pretty nice. So everything you store in there is not accessible to JavaScript code or to a user or to anything. It's exclusively used to send information to the web server to identify you. Yes, question? It does, and I'm going to show that in a second too. So now let's go back to our dashboard. So we just fixed the login page, right? But we still need to fix the fucking dashboard. It sucks. So what we're going to do here is we need to find out if a user's logged in or not so we can say you're allowed to visit the dashboard or you're not allowed to visit. So what we're going to do is we're basically going to say, hey, if there's no user ID available to us in the session, redirect the user to the login page. Otherwise, we're going to use this find by ID command that Mongo has, and we're going to basically grab the user from Mongo by their ID. We're going to get the user object back. If no user is found, we're going to redirect them to the login page. But if the user is found and everything's good to go, we're just going to show them the dashboard page because guess what? They're logged in, they're happy, they're good, they're secure, whatever. All right, now, we have the basic stuff working, but a lot of you are probably cringing because you know that in the Mongo database from earlier, the password was just stored in plain text. And you're probably thinking, wow, this guy is giving an authentication talk, and he's a total noob. That's OK. I understand. So let's fix that. Let's talk about password hashing, OK? The first thing you need to know about password hashing is that when you take a password and you hash it, you're just running it through a function, OK? So it gets some input, and it spits out some output. The output is always going to be a really long-looking, random-looking string, OK? Now, there's only 2 rules you need to know about password hashing to know more than everyone who works at Yahoo Security. The first one is that the same password always generates the same hash, OK? So if I calculate the hash of my password, which is ABC, and then I calculate it again, those 2 long random strings are going to be the same. Because the input was the same, the output will be the same. Now, if you're going to talk to me about salting or whatever, hold the questions till later because I already know. Don't worry. The second thing you should know is that given a hash, you can never retrieve the original password that created it. So once you have this long random string, there's no way to get back that original password that was ABC. It's called a one-way function because it takes input in, it spits output out. But once you have the output, there's no way to like decrypt it per se. It's just a one-way function. Sound good? That's what makes hashing awesome, by the way. Now, you've all probably heard a little bit about hashing throughout your careers. If you're just getting started, you will hear much more about it, I assure you. What I have on the left are a bunch of popular password hashing algorithms. Now, I'm going to do a little bit of a smackdown here, so get ready. So, like, a lot of things on here are really, really bad. And if you see them in your company's code base or in your code base, you should feel bad, you know? I'm just joking. You shouldn't, but you should probably fix it. Now, MD5 and SHA-256, there's a ton of different hashing algorithms I'm not listing here. I'm trying to list the ones people typically know about. But a long time ago, back in the 80s, I believe, MD5 was created. And it was a really simplistic hashing function. Now, over time, cryptographers realized, like, hey, we need something stronger. And I can explain why later if you guys have questions. But basically, they created the SHA series of hashing algorithms, including SHA-256. That is also incredibly weak by modern standards. The ones I've listed down here towards the bottom are the ones that I personally consider safe to use. There's bcrypt, which is a very well-vetted and popular hashing algorithm. You'll probably hear about that a lot. There's scrypt, which is another extreme, oh, by the way, bcrypt is created by Bruce Schneier, an extremely prominent cryptographer. He's also the author of a bunch of really awesome cryptography books, which I strongly recommend you go read if you're interested in this stuff. And he does a lot of open source blogging and stuff like that. Really cool guy. Scrypt is a relatively new hashing algorithm. It came out in 2006. The guy that created it, Colin Percival, is another extremely famous cryptographer. He's the head of security at FreeBSD. He runs Tarsnap, which is a very secure online backup service, and does a lot of other really cool things to help keep people's information safe. Scrypt is significantly stronger than bcrypt. And finally, there's Argon 2, which came out about 2 years ago. I've had the pleasure of sitting down with the guy that created this, Jean-Philippe Amessen, and basically, this is the future of password hashing. In 10 years, I would be extremely surprised if this was not the gold standard for what password hashing is. This is going to become a new NIST standard, which means that in the future, after the government organizations do their thing and everyone gets in feedback, this is likely to become the new standard for password hashing. Now, what I recommend people do today, if you're working on a project today, is use bcrypt. It's really safe. It's been around for a long time. It's a safe choice at any company. We'll never get any backlash over it. It's awesome. Oh yeah. Oh yeah, so in the etc category here, anything that's not explicitly listed on here is horrible. Don't use it. Including SHA-512, I'm sorry. Yeah. Yeah, so Argon 2 is available pretty much everywhere. If you Google it, there's actually two versions. There's Argon 2D and Argon 2I. Depending on what you're using it for, I'd recommend a specific one. We can ask me later if you want. But yeah, it's available if you guys want to mess around with it. I've actually written a few blog posts about it. I did a really cool podcast where I interviewed Jean-Philippe about it. If you Google it, you'll find that stuff. Yeah. They're all exponential performance differences between these last three. Yeah. So the question is, if he's using bcrypt now and he wants to upgrade to Argon 2 in the future, can he do that? Yes. I can explain strategies for that later if you want, because it might bore everyone else in here to death probably, but that's a great question. All right, cool. So also, let's take a look at how bcrypt works, just pseudocode, so everyone is on the same page. So you have a password, you bcrypt it, and you get back something that looks like this. Now this is an actual bcrypt hash, just so everyone can see what it looks like. Now, if we want to improve our registration page so we're not being noobs and just storing everything in plain text, no offense, by the way, what we're going to do is we're going to use the bcrypt.js library. Now, one of the other problems that I've seen, which I just want to point out, is that if you look for bcrypt on NPM, if you look for a package to do this, there's a bunch of them. And they are not all of equal quality. I personally went through every single one and did a lot of vetting research, and I strongly recommend you use bcrypt.js specifically. It's a little bit worrisome to me, actually, because quite a few of the other ones have massive download accounts, which is a little bit scary. Now, anyways, back to the code. So if we want to improve our registration code, there's really only 2 lines we need to insert to make this work. We need to define this hash, and what we're going to do is we're going to use the bcrypt.hash method, and we're going to give it the password the user just submitted to us from the registration form, as well as this magical number 14. Now, this magical number is called a bcrypt work factor. And in reality, I would not hard code this into my project. I'm just doing it to showcase it easily. But basically, a work factor is a number that tells bcrypt how strong this hash should be. The current standard is 14. And all this really means in reality is in bcrypt, you can specify these numbers, and the higher the number is, the more secure the hash is. But if you go too high, it's going to take a massive amount of time to calculate this hash on your computer. It's going to use a ton of CPU, which is a bad thing. So if you guys just want to know more about that, hit me up afterwards. And then finally, what we're going to do is override this password with the hashed value. That way we don't store the plain text password anymore when we create the user. Did I lose anybody? Sorry. No? Okay. And that's pretty cool, I think. Little animated guy there. OK, so now let's go back to login. Now, because we just implemented that in our registration code, right, we broke all of our login code. Because what's the situation now is that if I go to the login page, type in my information, and I go to log in, what this code is going to do is it's going to compare the plain text password I have to this long random string in my database. And those two things are obviously completely different, so the login will fail. So what we need to do to fix that is use this bcrypt compare method. And what this does is you give it the plain text password the user's putting in the login page, as well as the user's actual password hash, which comes from the Mongo database right here. And bcrypt will basically check that these two things are the same by hashing the plain text password and making sure it equals the one in the database. Because remember before, the first rule about password hashing is they always generate the same thing. Same input, same output. And then finally, everything else in here stays the same, which is cool. Yay. All right. So right now, our improved user in the database is starting to look pretty cool. We have a hash password. It's bcrypted. It's pretty safe. Like, nothing bad is going to happen to us. Now, how many of you in here are looking for a job? Like, actually looking for work? Like, throw your hand in the air. So if you want a really easy job, like, no questions asked, go to this website, plaintextdefenders.com. It lists all the companies that are storing all their user passwords in plain text. And tell them you just saw this awesome security talk, and you can go and fix their security stuff for them at their company. It's an easy in, I'm telling you. And if you don't need a job, you can just go there and laugh and look at all the websites that still store things in plain text. It's pretty hilarious. All right, so next up, let's talk about middleware. If we want to define some middleware to make this thing a little bit easier, it's actually super simple to do. What we do is we define this app.use statement, just like before. You know, it runs before every request. And what it's going to do is it's basically going to say, hey, if there's no session data available, like if there's no cookies, then just keep on doing whatever you're doing. Like keep on going to the login page or the registration page or what have you. But if there is a session available, we're going to try to extract the user ID out of the session and load it using Mongoose. So we're going to talk to the database and say, hey, this cookie has this user ID in there. Give me the user object back. Then what we're going to do is we're going to do three things. We're going to create this object called request.user. What that's going to allow us to do is later on in our code, it'll allow us to use this request.user object to do stuff to the user. So maybe later on you want to see the user's first name. You could say request.user.firstname. Or if you want to override that value, you could do that. You can do anything your heart wishes. Also, we're going to set res.locals.user. Now, this is an Express-specific thing. But what this basically says is, like, if you set a variable here called user on this locals thing, in any templates you have, you will automatically get a user variable available to you. So in your pug template, you could say user.firstname to say, hello, Randall, on the dashboard, or something like that. And then finally, what I'm going to do here is, I'm basically going to override the password hash with nothing. Because in my experience, it's extremely easy for developers to accidentally console.log a user object that has a password hash in it, for instance, which leaks that out to the world. And that's a really bad idea. Now, this is what I'm showing you in here to keep this simple. A better thing to do would be to never even pull the password field out of MongoDB when you retrieve the user. And we can talk about that more later if you're interested. And then finally, the next middleware we want to do is something that requires a user to log in. So on our dashboard page right now, it's hella ugly, right? Because on the top of the route, we have to say, is there a user? Give me the user. Is there a user? Give me the user. It's very redundant. Now, if you have a lot of pages on your website where people have to be logged in to access them, that would be really ugly. So what we're going to do is define this really simple function called login required that all it does is says, yo, if there's no user, send the user to the login page, which will force them to log in. Otherwise, let them do whatever they wanted to do. And what we can do now is we can go back to our dashboard code from earlier and insert this login required thing right there. And what this says is like, hey, if the user tries to go to the dashboard page, run this login required function. The login required function will check to see if the user exists. If they exist, it'll come down here and it'll run this function. But if it doesn't exist, it will redirect them to the login page. It's pretty cool. So that's it for the basic stuff. Now let's talk about some additional web security things that apply to this, namely CSRF. So throw your hand up in the air if you know what CSRF is. OK, cool. This should be good then. CSRF stands for cross-site request forgery, which is a bunch of long words that don't really mean anything. I find it a lot easier to just show you. So imagine your banking website has a page called withdraw, okay? And on that page, there's a form that has 3 fields: the account name, the amount, and who you want to send the money to. Pretty easy. Now, what would happen if someone sent me an email like this, where inside of the email they send me, the browser is going to load this URL, which it thinks is an image, is going to try to request it, and it's going to open that withdraw page, and it's going to submit a transfer of $1 million to my account. So it's going to try to steal my money. This is called cross-site request forgery because basically someone is tricking you into clicking a link that does something automatically without you realizing it. That's all it really means. And this is sort of a bad thing. Like, who knew, right? So the way we solve this problem in web stuff is with CSRF tokens. It's a really easy concept to grasp. So when you log into a web server, the web server is going to generate a unique token, like a unique ID basically, called a CSRF token. It's going to embed it in a login page in a hidden input, in a hidden form input, excuse me. So in your login page, there's going to be a little new input field there, type hidden, called CSRF token. It's also going to store that value in a cookie that goes back to your browser, okay? So then when you go to actually submit your information to log into the website, you're going to send a post request to the server with all your login details, including that randomly generated CSRF token. And so the server is going to say, hey, there's a CSRF token in this form, and there's a CSRF token in this cookie. Are they the same? If they're the same, we know that the user has already requested to view this page before they filled out the form, so they're good. If not, then someone's trying to trick these guys into doing something, so we're just going to reject their request straight up. So they say no, basically. Does that make sense to everyone? All right, cool. And the way that you basically insert that hidden input thing into all of your HTML code is just like this. So you just add a hidden input field. The name is going to be underscore CSRF. The value is going to be a variable called CSRF token. And then what happens here is on our server side, we need to install the tools to make this work. So the tool we need is CSURF. We import it. We set up the middleware. The middleware here is what's going to generate these tokens for us, set the cookies for us, compare the values for us. It does everything. All we need to do is whenever we are rendering a template that has a form in it, all we have to do is pass this value in, and it handles everything else. It's pretty cool. Oh, and that makes it secure. Ha. All right. So now, real quick, security best practices, and then we're done, I promise. So, number 1, always use SSL. This is probably obvious to everyone in here. But if you're building a web project and it's not running on HTTPS, right, then it is not secure. Because no matter what way people log in, your information will be stolen. I'm telling you right now. The reason why is that anyone, so if you're not using SSL, basically, when you make a request from your browser to a website, it goes to your internet service provider, it goes to like the NSA data centers, it goes to like the Canadian Mountie data centers, it goes to, well, maybe not those, but everyone else basically sees a copy of this information. No one laughed at that. I thought it was so funny. Damn. Anyways, everyone sees a copy of it unless you're using SSL because that guarantees that your browser and the website, everything that goes between the two of you is encrypted and no one can see it. So the next thing up is cookie flags, which this guy was asking about earlier. Great question. So when you're storing cookies on a browser, there's really 3 options you should always be aware of, and you should probably use at least 2 of them. The first one is HTTP only. What this option does is it tells the browser that you should never let JavaScript code ever access this cookie. And that's extremely important because all of you are most likely using Chrome or Firefox or something where you have extensions installed. Extensions are just running JavaScript code on every single page you go to. So someone could create an extension that changes their mind tomorrow and basically says, hey, grab this person's authentication cookie, send it to me, now I'm going to like start making requests to their website and steal all their Bitcoin. And that's happened, by the way. That's not fake. The next thing, the secure flag. This basically tells the web server that unless you're using SSL, refuse to set a cookie at all. Just straight up refuse it. Say, no, I'm not going to give you a cookie because things are not encrypted and that's not cool. And the final option you should know about is ephemeral, which basically says that no matter how long your cookie is supposed to last for, like no matter what that expiration time is, when the browser closes, kill the cookie. That's really important for people that are writing applications that are going to be used on like shared computers or like a library or something, or if people are writing banking apps or healthcare apps where the information is critical. It's probably a great idea to just kill the cookie when the user closes the browser, just to be safe. Next up, wear helmet. So there's this awesome library node, which is called Helmet. You can install it and you can use it like this. It basically does a lot of things with HTTP headers to keep your website safe. Now, there's a huge checklist I just copy-pasted from their README right here. But basically, it does things like using HSTS, which is basically telling people that your site must be used over SSL at all times. It does all sorts of cool things. You can look it up on their NPM page or on the GitHub page. It explains everything. It's really nice. And finally, the most important thing of all is that even though I'm walking you through this and showing you how to do it, it's ideal if you don't do what I'm doing. So I actually write authentication libraries for a living. Like I've been doing this for years and years. I do a lot of this work open source and a lot of this stuff for paid users and things. And the most important thing I can tell you is that security is not hard, but the edge cases are hard. So like making sure that you don't mess something up somewhere, like making sure you don't accidentally console.log a password hash, or making sure your database server, which is holding this stuff, is properly secured and is like not public on the internet with no password, for instance. There's all sorts of ways to mess this stuff up. My recommendation, use an open source library when you can. If you can't, maybe you want to do it yourself, or maybe you want to use a service that will help you with this stuff. So here are some options. You can check them out. There's probably a bunch of other ones that I'm not familiar with. So yeah. So all this code is up on my GitHub, refactored and pretty and nice. These slides are up on my speaker deck. I will post a link to them in the meetup, later tonight or whatever. And if you want to see the embarrassing things I post on Twitter, those are the accounts I use. And the Okta one is particularly interesting because we're doing a bunch of really cool security things lately, which might interest you. So thank you guys for having me. It's been super cool hanging out. It was a pleasure. We probably just have a couple minutes for questions if anyone has a few, I'm happy to answer them. Yeah.
I've always used Passport for this. Is there any security concerns in using Passport that you can think about?
Yes. So the question is, are there any security concerns when using Passport? The answer is yes, because Passport requires you to do a lot of stuff yourself. So even if you're using Passport local, which is what I'm assuming you're talking about, you still need to implement a lot of that logic on your own for the backend to make things work. There's always massive risk when you do that, because you have to make sure your database stuff is secured properly. There's just a lot of edge cases, so the answer is yes. Yeah. So the question is, how many bits is the bcrypt hash? I'm trying to remember off the top of my head. The maximum input, I'm going to butcher this. Someone's going to Google and hate me. I think it's 82 characters. 82 bytes worth of ASCII characters is the maximum input to the hashing function, although you can get around that by doing this separate hash, basically. You can do a SHA hash to get a smaller thing and then pass that through. Oh, so the question is, can password hashes be brute forced? Like if you just attempt to log in over and over again with different passwords, will that work? The answer is yes. Every single password hashing algorithm in the entire world is susceptible to brute force attacks. So the only thing that makes password hashing algorithms like stronger than other ones is the amount of resources they take to compute a password hash. So let's say, for instance, that bcrypt function from before, right? Every time you run it, let's say it takes 2 seconds to generate that long random string. That means that if someone wants to try to guess your password over and over again, it's going to take them 2 seconds for every guess they make. So one way you can slow them down from guessing it is you can make that time take longer and longer and longer, more and more resources. A quick breakdown, so bcrypt takes a lot of CPU resources to compute a hash. scrypt takes a lot of CPU resources and a lot of memory resources to compute. Argon 2 does not only those 2 things, but also the amount of physical CPU cores that need to run concurrently to compute the hash. So it uses all 3 dimensions to make hashing extremely difficult. Like, you can even do cool stuff with Argon 2, which is going to freak people out here, right? But like, let's say you're running massive Amazon web servers that have tons of CPU cores. You could be a total jerk and basically make your scrypt or make your Argon 2 password hash require like 32 cores in order to compute a single hash. That means that an attacker who's trying to guess a password would not even be able to compute that hash on any computer they have unless it has a minimum of 32 cores. And that's pretty awesome. So there you go. Yeah, so he's saying it's going to take, the stronger you make it, the slower the login process is. That's absolutely correct. One of the nice things about Argon 2, in my opinion, is that you can customize all these parameters. You can say, hey, it should require this much CPU, this much memory, and this many CPU cores to compute a password hash. CPU cores are typically cheaper in terms of complexity because they're not slowing things down tremendously versus like memory, for instance. If you say this requires 20 gigs of RAM to compute a single password hash, that's a lot. It takes longer to fill up that memory, you know? Like just literally like in the RAM. All right, okay. Hopefully that helps answer. Other questions? No? All right, cool, well hit me up afterwards if you want. I'm always around, so it was great being here. Thank you.